We have our final, delighted with the presentation we have from a really innovative company with some really innovative biosolutions. So that's the last presentation of the day, and then you can all have a very well-deserved glass of wine or beer. So please welcome to the stage Lucie from Newera Bio. Hello. How you doing? Go for it. Have fun.
Thanks. Oh, yeah. Perfect. Perfect. All right. Hello. Thanks for being around for the last talk. I don't want to take too long from your drinks. So we're Newera Bio, and we're re-engineering color for the world. So a great contrast exists in our world today, which is beautiful colors are actually sourced from oil, as many things. And this is really problematic because it's causing 20% of global industrial water pollution. It's leading to significant greenhouse gas emissions, and it's harming biodiversity and human health. So this is creating a strong push towards non-toxic, biodegradable, renewable materials for color. A lot of the regulations that are coming out are from Europe to restrict toxic chemicals used in the textile industry. We see new regulations like the digital product passport that are increasing transparency through the supply chain, where the consumer will be able to understand what chemicals are used in what they're wearing. We have other regulatory policies such as the one substance, one assessment, which has come out in January this year. And this will really increase the speed at which chemicals that are banned in, for example, packaging and toys will then also experience the same scrutiny in textiles where they're typically ignored today. And this is creating a pressure on brands. We see that brands are coming to us looking for cleaner solutions for dyeing, and they need to report on their sustainability metrics yearly. And this is something that, initially they were just interested in the fiber because that consists of the majority of the fabric. But, like we know, methane is not a majority molecule in the atmosphere, but it also creates a lot of damage. So this is the same for textiles. They only make up 1% of a fabric, but they wreak a lot of havoc on the environment. And unfortunately, legacy players like plant-based dyes are not creating an alternative solution. So we see that textile mills that we talk to are having a hard time finding cleaner dyes and auxiliary chemicals, because when they use plant-based dyes, they actually need to use like very long dyeing times and very high temperatures. And they're on razor-thin margins. So adopting plant-based dyes just doesn't cut it for them. And also the performance is lacking as well. So the colors still fade. So imagine if there were textile dyes that gave lasting results, but without the lasting harm. Currently, bio-based alternatives exist. Over the past decade, several companies have come out making fermentation-based colorants. And unfortunately, they're still missing the mark. So not only are plant-based dyes missing the mark, but also bio-based dyes are missing the mark. And the reason is because some of them still lack in color performance. So they would require metal mordants, which are not eco-friendly to bind to the fabric. Others are just restricted in the fabric that they can apply to, so they'll only be applicable for polyester or only for cotton. And, the industry is used to versatility. Synthetic dyes are able to be generated with chemistry to bind to any fabric type of interest, any color generated, and really these bio-based dyes are just not able to compete on that level. And of course, as we know, like all things biomanufactured, or most things biomanufactured, the price is quite divergent from what the industry is used to paying, very dirt cheap prices. And other innovators have developed colorant technologies that actually require the textile mill to adopt fermenters and buy fermenters in their textile mill, which again, being on razor-thin margins, they just aren't able to do that, and it creates a huge bottleneck for adoption. So we're creating a bio-based platform using not just fermentation, but really coupling biochemistry and chemistry into the picture as well to help in this problem of, high performance and bio-based, but also to remove the very significant pricing of the bio-based dyes. So we're on track to making the cheapest high purity indigo at a kilogram scale this year. And this is really important as well because we're using our proprietary technology to improve the ability of this indigo to bind to different fabric types. So not just for denim, but on silks and wool and nylon as well, which really expands the use of this one molecule. And that's the way that the industry really can adopt these bio-based colors, is to allow for the versatility and the high performance that the industry is used to with synthetic dyes and impart those features onto these bio-based molecules. So we have a trichrome range that is really interesting for brands because then you're able to start mixing the colors to expand the color range, red and blue to make purple. And most importantly, we make sure that they're a drop-in solution, so they're provided as a powder, and they don't require any capital expenditure from the textile mill to adopt any fermenters. We just provide it as they're used to, just a drop into a synthetic dye. They are scalable via fermentation and biochemistry, and we have patents for these as well. So we have taken a lot of effort to improve their ability to bind on different fabric types. As mentioned, like with indigo, it's really poor at binding to anything besides cotton and denim in particular. So we've expanded its ability to bind to wool, silk, and nylon without needing to use very harsh chemicals. And the dyes themselves have antimicrobial properties, which is another added value proposition for brands so that they can give anti-odor claims. They're tested for their biodegradability, their toxicity, and against the zero discharge of hazardous chemicals to ensure that they don't contain any restricted substances. And because we use chemistry combined with fermentation approach, they're anywhere between 70 to 100% bio-based. And when we developed our dyes, initially we also realized that the industry uses synthetic additives during dyeing. So they don't just use synthetic dyes, but they use sometimes very harsh chemicals to get the dyes to bind to the fabric. So we wanted to provide a whole bio-based solution to the textile industry, and we developed a botanical formulation called BioBind, where we can improve the dye uptake of the bio-based dye by at least twofold, and it can still maintain its color fastness when washed. And we've also increased the light fastness by a whole level up as well. So these are easily scalable, and they don't contain any metals, which is really something that's allowing for the industry to adopt a cleaner additive as well. And beyond just textiles, as we know, silk and hair have very similar molecular structure. So we found that when we use the binders on hair, the wash fastness of semi-permanent dyes was greatly enhanced. This is super interesting for the industry because as they want to move towards gentler formulations and away from the permanent hair dyes that require nasty developers, they still want the customer to experience this long-lasting wash-fast color. So by applying our binder to semi-permanent, we can achieve closer to permanent hair dye result without needing to use any harsh chemicals as well. And this can also help the brand to reduce their COGS because they can reduce the amount of dye that's in the hair dye box, which is the expensive component. So our team is a globally diverse team to solve this major global problem. I started the company with my co-founder, Shin, just over 2 years ago, and my expertise is in microbiology. She's a synthetic biologist, and we have chemists on the team as well, and other biotechnologists to help bring this whole solution together. And we also have great advisors. Professor Black, has a color in his name, so that helps. And he's really Australia's legend of indole and indigo chemistry. So he's really helped us in understanding how we can improve our chemistry side of the technology. And also Paul Cowell, who has previously worked with BASF and made thousands of synthetic textile dyes. So we get really great insights from him on what we're trying to replace. And our investors are Main Sequence Venture, one of APAC's largest deep tech fund, and Bioplatforms Australia. And we've spun out of the UNSW Founders Accelerator. So we're on a mission to decarbonize and detoxify the world's color system. And we want to make color work for the planet, not damage the planet. So we're really excited to transform our wardrobes into something that is much cleaner. So just to wrap it up, and you can go and get your drinks very soon, we are raising a seed round of 5 million AUD and have secured half of that with our lead investor. So we're just looking to close the remaining half of the round. And I've already chatted to so many amazing people at this conference today, but just to reiterate, really interested to talk to any strategic partners for scaling and any brands or mills that are interested and suppliers for our products. Thanks so much.